how should we think about AI? If we're going to say we shouldn't define it, right? Because trying to define it is hard and limiting. If I asked anyone in the room to come up with a definition, there might be something that we would all agree is AI that wouldn't fit the definition, and something that is an AI that would fit the definition. And so trying to draw those lines can be really difficult to sort things as well. And then there's, terms that are even coming up like agent and stuff, and that can be difficult as well. I think another thing to kind of hone in on is the term AI generated has been a fun one, because it's kind of a negative or funny term. You can imagine someone says something in your class that sounds very stereotypical, and you turn to your friend and be like, "Wow, that was like a AI generated comment," meaning it's stale. They didn't really say anything of substance. Um, and so that's something to consider as well, that like a lot of people are coming at AI from a lot of different angles as well, and there's a lot of different narratives out there too. And as the technology progresses, the definition will become even more diluted. I think that's something that's important to understand as well, because I was kind of joking about the on that first slide, the AI air fryer that like senses when your food is done, but like that's probably something that will happen in like 30 or 40 years. You can imagine that you talk to someone who grew up with an AI air fryer and they don't even like put a timer on or check on the food. They just like put their broccoli in, and it takes a picture, it knows it's broccoli, it puts it to the exact right settings. It's taking a picture maybe every minute or so and checking, and it just stops cooking. And when it's done, and kind of like a timer goes off or something. And so at that point, it would actually be AI powered. And so finding that line can be really hard. And the point I'm going to make is that we shouldn't try to define it at all. But I think it's still valuable to understand where we're coming from. And so I've sort of set up this Padlet. This can also be a good check of if the audio situation is working out or if we need to figure something else out. But I have a Padlet, and I want to just start by kind of figuring out where everyone is coming from. And so I have this question, and if you scan the QR code with your phones, you should be able to just like add a comment on this board and answer the question, what do you think of when you hear AI? It doesn't have to be a definition. It doesn't have to be anything. Like it can literally just be like, when I said that word, like what was the first thing that came to mind, or your opinions on it. But it might be nice to just kind of look at all of these. And I think when you post, you should be able to see everyone else's as well. And so you can see, should be anonymous too, where everyone else is coming from. And I'm gonna hand it off to Jason. So just in person, he can sort of go through some of those and maybe report back to me. I'll look as well where people are at, what we currently know and think about and hear about AI.
I definitely kind of agree with the whole LLM ChatGPT thing. I think of also I think of I mean, now that I know a little bit more, I can't help but like think of like the AI algorithms, any type of like ranking, like a lot of the ways that like they're trying to receive information like Google search, that AI generated bit where it summarizes all the web pages,
Right.
provides you links. It's definitely AI. I mean, what's your name, by the way?
Sam.
Sam, nice to meet you. What's your name?
Aaron.
Aaron? Nice to meet you.
What's your name?
Jason.
Jason.
Yeah, yeah.
I mean, you know.
Wait. Does it start with a J? That is my name. No, I met another. No, I dead eye. No, dead eye. Other Jason the other day. So he was like, if he knows that I know. Wait. Hold on. There we go. Yeah. What do you think of AI?
AI.
Supercomputers? Yeah. What about you guys? The future? What about the future? Do you think air frying machines are the future? Or AI powered batteries? A Roomba perhaps? Financial.
Generative.
Yeah.
Are you the one financially? But isn't
I mean, do we want AI to run the money in the world?
Not to run it, but
they're also.
How'd that work? Where do you draw the line of what AI can do, what AI can't do?
you can't help out government funds or dispatchment and help them solutions.
Yeah.
And advice from a budgeting account.
Something like that, yeah. And then aside from that, though, like.
Okay,
We're gonna go talk
let's
to
try
us
to
on the phone.
wrap up these conversations.
Like
Maybe
wrap
Jason
up.
can share out a couple of them and then put it well there. And it's cool to see you guys kind of have this conception of ChatGPT and like the modern sort of AI wave that's going on. Because I think for me, too, that's when I really got to start be excited about AI. And I think that is what generally people think of out in the world. Here, we're going to try to be a little more in depth. And so I think this is a really good place to start. And the first thing I want to do is go and look at some actual definitions because I've been talking a lot about like don't define it, like whatever. And but you guys can come to a different opinion if maybe you think definitions are useful. And so we'll look at two definitions that are commonly used. So the first is from Oxford, the theory and development of computer systems able to perform tasks normally requiring human intelligence. So this is a pretty good one. Some problems I think it has is like, does that mean like only human intelligence? Like if you could teach your dog to do it, does that mean that like if an AI did it, it's no longer considered AI because, you know, something other than a human can also do it and use intelligence? And then one, we'll get into this because we're going to get into the history, as Jason was hinting at. Kind of before there was actually any hope that these things were possible, machines I could think, there was the definition, the science and engineering of making intelligent machines. And I like this one a lot because it doesn't try to make any claims, and it kind of frames AI as a field, which I'll say in a second, but I think that is the right way to think about it. And I think that can really help us all broaden when we think about AI, broaden what we think about, because we can think about it as a field, not just one technology, not just one wave, but fields kind of have a lot of different things going on within them, and they have a lot of different times in history where they had progress and slowdowns and such, and we'll start to look at that here. So how do we define it? Like I've been saying, I kind of have given this one away already, but don't try to define it or categorize it. It's not going to be too useful. And I think if someone, you know, like put you on the spot and asked you to define it, then that wouldn't be the greatest thing. And instead, I think it's useful to understand the history of it because it seems like a lot of us are kind of coming into this with the idea of like the modern AI revolution. And hopefully we'll look later in the quarter at kind of how that came to be and everything that goes into that. But it's nice to look at the work that came before it because even if that work didn't directly build into this, it still laid the groundwork for a lot of the things. And sort of the computing field in general did a lot of things that laid the groundwork accidentally as well. If you think of like GPUs, which were made to run games and to run graphical engines more efficiently. And then they now power the AI revolution, right? So there's a lot of overlap with computing as well, which can be interesting. But like I said, I think AI is a scientific field like biology. You know, you can define biology, and I think there are useful definitions. Though, if you were like labeling food as like biology or not, like that just wouldn't really make sense. And I tend to be of the belief that like the same thing is true for AI. That you know, it's not super useful to label things as like AI or not, and instead it's to think of it as like a field. And especially if you're interested in going into it, but if you just are going into biology, you know, the question someone will always ask you is like, oh, like what in biology you're going to go into? And I think pretty soon with AI, we'll kind of have a similar thing where it's like, oh, well, what in AI are you going to go into? You're going to go into computer visions or large language models or this more integrated vertical AI systems that are just using machine learning on a specific task or something like that. Or there's NLP and there's overlap between these things, of course. But that's like a useful way to think about it. And I think the first way to understand the field is to look at the history of it. Because we have the luxury of like, you could say something like biology or chemistry has always existed and we just sort of like discovered it. But I wouldn't say the same for AI. I don't think it like always existed and we discovered it. I think, you know, people made breakthroughs along the way that actually made it to be possible. And like I said, a lot of those breakthroughs were accidental or in other fields as well. So first, we'll just look at kind of the history from 1950 to 2005, because a lot happened and not a lot happened at the same time, right? Because, you know, if you've kind of learned the history of computing, a lot of the things are going to be related to computing here. And those kind of, again, laid the groundwork, but weren't directly related. So in the 1950s, when computers were kind of first becoming prevalent and being invented, people actually got really ambitious. They thought that because you could kind of do these math problems and you had like a computational machine that like you could basically make an intelligent machine. They thought like it was that easy. Like there was just some pathway. They didn't know what it was, but they thought you could just scale it up a little bit and do this. And so that's when the idea of AI is coined. Like, okay, computers can do math. Math is something we consider to be human intelligence because other species do not do math. And so maybe it's possible that we could have intelligent machines. And that was really ambitious for the time, and it did not turn out to be anything close to it. I think there's some early examples. I want to say like it's called ELIZA or something that just uses like logical programs. So that can be a fun one to look up as well. And if the first couple of questions, you maybe think it's intelligent, and then you quickly realize it's not adaptable at all. And so maybe that's something that intelligence has to be is adaptable. So there was a lot of progress in the early 1970s, or in the 1970s, sorry, and people got really excited again. And there was a lot of talent going into this, a lot of money, and people there was early signs that you could sort of train algorithms instead of just kind of doing these logic-based programs. And so a lot went into that. People got super excited again. And then it just didn't turn out to be that useful. It didn't turn out to be that consistent. The gains weren't what people thought it would be. They were kind of extrapolating out these trends that like didn't happen. And that's when you get the term AI winter. And you may have actually heard that term nowadays because people thought at the beginning in like 2022, 2023, 2024, that when we were starting to see this progress in AI and we're putting so much money and so much talent, that maybe we would have a similar thing, that maybe we would hit some fundamental limit, or we would kind of hit a wall, and it would be more like crypto, and then people would lose a lot of money. And I mean, some people still think this is going to happen, and it's possible it happens in some regards. But that was kind of an early example, maybe something we can learn from as well, is that period of time. And then later into the 1990s and the 2000s, this is when the internet, starts to really take place. And I think that's important too, and I'll get into why that's important and why that really set the stage for modern AI. But there was the rise of machine learning and limited domains and private development. So this is more sort of like granular or very specific tasks that machine learning was showing promise on. People, they were better optimized. And again, it was the thing where like there was no hype around it. There wasn't people saying it was going to change the world at the time. It was more just like breakthroughs that people were doing. Research papers were coming out, and there was still a lot of buzz, and people were still thinking about these things, maybe just without the headlines. And so I think this is like I've called it foundations, because I think that really laid the most important groundwork for what we see today, because a lot of things that we do today are just advanced or scaled up systems that came out of the 1990s and early 2000s. So then, oh yeah, I want to highlight three big moments. These are all really cool. And there's plenty of YouTube video essays that I recommend if you're interested in AI that you watch, because I think when you get into the field, like people will talk about these moments, and they really are important. And they're moments that kind of seeped into the larger culture at the time. Like even people who weren't interested in AI maybe were talking about this in the same way that like they're maybe talking about the moment like ChatGPT came out. The first one was IBM's ChessBot. It beat the #1 chess player at the time, and people again got really, really excited, and thought, like they thought chess was something that required human intelligence, and if a machine could beat the top chess player, like that really meant something. It turned out that like it was good at playing chess, and it was not good at doing anything else. It was a very narrow domain, and it also turned out that chess, when you get really fundamental, is computational. So it wasn't even kind of making these conclusions or generalizing about chess. It was just kind of picking the best computational move at every step, and that allowed it to beat it. There's another thing I want to highlight here, is that people still play chess today. And I think that's really important, because sometimes we hear things that like AI is going to be better at this thing, and that really matters. Like if AI is better, then we can all stop doing it, because a machine does it better, and who cares anymore. But people still like to play chess. They still like to learn. And I don't think there's ever a chess player who's kind of like sitting down being like, I want to go beat AI at this game. Like it's just not possible. But it just doesn't really matter. People still want to be the best chess player in the world, be the best human at chess. And I think that kind of gives me hope as well, because sometimes people frame it as like, as soon as AI beats something, that thing will become irrelevant. And I don't really believe that. AI's Big Bang moment. These are sort of famous people, Geoffrey Hinton and Ilya Sutskever. He's on the left there, and this was a lot of events happening at once. I think the competition was called ImageNet, and that was like the first sort of open source competition for labeling of images and classification of images through computer vision. Computer vision was thought of in like the 90s, but like this was the first time that we had a data set where we could kind of see, can a computer classify images? Can it look at an image and decide what it is? And a lot of very rudimentary approaches were taken to try to like gamify the system and like what we would maybe think of like as reward hacking nowadays. And people got like decent scores doing that. And what ended up happening is this team of three, but I'm sure they had more help than that, kind of used a more general approach and used neural networks on GPUs to train what I believe they called it AlexNet, and they just like won the competition. And that really showed people at the time, like, okay, we can use GPUs, we can use neural nets to actually train and get like really good results that we don't fully understand, but that are super powerful. And these people had been working, Geoffrey Hinton speaks a lot. He had been working on these things for a long time, and he kind of credits this moment to the moment that showed GPUs were what neural nets were actually missing at the time. Move 37, this might be something you've also heard maybe out in the world, or maybe I'm on Twitter too much, but it's this really famous move where Google, who they have a lot of alpha models which are trained with reinforcement learning, and they had this AlphaGo model which learned to play the game of Go. And it was, again, against the best Go player or one of the best Go players. And when it got to the 37th move, this guy is moving it for the computer, and he looks down and it kind of makes this move that like no one's ever done, or no serious player would ever do in a real game. And he makes the move, and it's actually like a really brilliant move that no one had done before. And so what that revealed in that moment was that like AI could figure out something novel. It could figure out something new to do, even though it learned from playing itself. It used reinforcement learning and played itself, hundreds of thousands of times. It learned something that like other players hadn't learned, and it actually went on to win that game, mostly in part because of that move. So it's, again, these are really just cool moments, and I think if you can learn a lot from just watching a video on each one. So I highly encourage that. Kind of moving on, so those were all between like 1998 and like 2013, I think, somewhere around there. So then between 2005 and 2019, I think we don't get as much hype. I think we get those big moments, but they don't seep into the larger culture as much, or not for as long. But deep learning starts to show promise on vision-based tasks. That's the thing with Image and AlexNet. AI starts to power algorithms across the most popular software products. So this is the time where, behind the scenes, people aren't making a big deal out of it, but Facebook switches from a chronological feed to one that's powered by recommendations. And Google Maps kind of optimizes routes based on that rather than using hard-coded logic. And data collection intensifies with mobile, which I'll get back to, but that's an important thing as well. And then in 2019, so this is what we were all kind of talking about in the last 5 years, right? This is when the first transformer models, when the paper came out, I believe that was in 2019. It might have been a little earlier. Attention is All You Need is a very famous paper. I suggest you read as well. But this is when sort of LLMs and kind of the modern day of generating generative AI came into the picture. So transformer models and scaling compute deliver LLMs. And at first they were just kind of promising, but we didn't know what would happen if we kept scaling them up. It turns out there's a lot you can do, and you can scale up a lot of different things. Diffusion models started to generate lifelike images and videos. And again, that's kind of just sort of accelerated. And then less in like the cultural text image side of things, models like AlphaFold and AlphaEvolve made real scientific progress. Again, I think these models, the alpha models from Google, are not talked about enough. They're really impressive. And a lot of times they're in scientific domains where they can like predict like millions of proteins, where before one protein would have taken a PhD student like 2 years to kind of figure out if it was stable or not. And so these are, and it's like open source. And if you work in these fields, you have access to it. So it's really, we don't see it, we don't hear about it because it's not that, cool or trendy, but they do accelerate scientific progress. And I think beyond, it's both over and underhyped right now. I think there's a lot of hype, like at the start, right? All of that is kind of overhyped. And I think in the long term, it's underhyped because people don't fully understand where the field is going and the amount of progress that's compounding on itself, which we'll get into as well. But we can at least all agree that AI labs are growing rapidly in size and value and cultural influence as well. AI development is considered a matter of national security. The two largest countries in the world, China and the US, both believe this, and they're both taking direct action towards each other to try to restrict development in the other countries. And there's a race to develop generally intelligent systems, and it really is a race. So why all the hype now, right? Because I mean, I kind of hinted at it, but we all kind of associate AI at a very high level or usage today with these modern systems. But like the history, it doesn't exactly kind of make sense how that all led today, or like why maybe some things were possible back then and now they're possible today. And I think it really comes down to scaling and scaling on three fronts here. So data, compute, and algorithms are what I've kind of coined here the fundamental units of AI. If you have enough data, if you can run compute on that data with a good algorithm, then you can train a pretty good AI at something. And if we look from 2010 to 2025, AI training compute has increased 1 million times. So that's the amount of training that would be used in a frontier model to actually train the algorithm that is used afterwards. And where all this data is coming from, of course, it's the internet and mobile computing is enough training data. You can imagine 20 years ago, you would have like cameras and people would take pictures and they would be on disks and like then you could maybe upload them to the internet and it wasn't accessible. But nowadays, of course, we're all kind of snapping photos all the time and then sharing them online. And then they're used to train algorithms, whether you want them to or not. If you're using a Meta product, they are. And algorithmic advances, I didn't want to get too into these because it's a little technical, and I think those are better to understand in specific areas. But these really optimize the algorithms and they push how far they can go as well. And I think that's really, really important to understand is it's not like you just throw data and compute at a problem and it solves itself. You have to really think about the algorithm and optimize it. But it's really complex and I don't even understand what really goes into that at a fundamental level. Okay, so that was a lot of talking. I'm kind of more interested now to know what what your current knowledge is on like models, architectures, and products. So I know people were saying like ChatGPT before. So maybe let's focus more on like the model and architecture side. Like what are some things you think of, or even if you're not really sure what the word model or architecture means, like maybe just some words you've heard that you think might fall into those categories, right? You don't have to be right or anything. It's just kind of to share out and see where everyone's at. And again, I'll hand it over to Jason and come back here in maybe 3 or 4 minutes, and I'll kind of speed run through the rest so we can move on to the boot camp it too. I might go a little bit over, but we'll try to keep it on time here.
Doing great. Doing great. Yeah. Don't worry about going too over. Like, don't need to rush crazy much. There's no one using this room after us, so we'll just go a little bit long.
Oh, yeah.
I mean, you can speed it up a little bit, but like, it's not your fault that it took so long to set up, and I apologize. It's not perfect, but yeah, you're doing good. Doing great. We have a lot of people here. I don't know. You can't really see how many people we have here, but the room is comfortably packed. So very exciting.
Well, I am.
Not really too familiar with like AI architecture.
Yeah.
But I do know some products, I suppose.
Mhm.
So I believe it's NVIDIA. I'm not sure which company, but I think it's NVIDIA.
Yeah.
NVIDIA is hoping to produce a game where the enemy, one that bosses is able to learn from
And then at that point,
the player's actions.
Yeah.
So each time that the player dies to that boss, the
Mhm.
boss gets harder and harder continually.
Yeah.
The question becomes, how do you prevent it from getting too difficult?
Yeah.
that's one like, product I know.
Yeah.
In terms of model architecture, I couldn't tell you
Yeah.
much.
It is something.
What about like companies do you know that produce AI, like big names?
Google,
Mhm.
Google that, Apple also produces AI, although that's more recent.
Mhm.
I know Microsoft produces, Microsoft produces AI.
Yeah.
And then they don't produce it, but things like YouTube or TikTok, they utilize AI. For their algorithms.
Yeah.
All right, I want to hand it back to Jason. Maybe he can share out a couple of things he heard, or anyone wants to volunteer what they know as well. I can't hear you though, Jason, so you're gonna have to tell me when it's back to me. Okay, I'm gonna take that as Jason is done leading the show. Okay, good. All right, moving on. I'm making a big generalization here, but I think it can still be useful to do this at the start. So what do all AI models do? Or you can think of this as all modern AI models, right? And of course, there's going to be some AI algorithm or something or a model that doesn't do these exact set of things, but it's still useful. So first, I should have said this in the bullet, but there's the training process. The training process is like when the AI model goes to school, it has to learn from data or examples. So that's something that's important to understand. There has to be data or examples. If you wanted to train a robot to walk around in the real world, you would either have to simulate that in some way, or you would have to have videos of people walking around in the real world. There's no other way to get around that. Once it's done training, you have a model that's done, and it's going to take a set of inputs and produce an output. So again, that seems simple, but it can be really useful to think about that. Like when I'm done training this model, what inputs am I getting and what output am I giving back? Am I getting in an image and saying whether it's a cat or not? Am I getting in text and trying to respond with like the best possible response to that is what ChatGPT does. And it's trained and optimized for good outputs. Again, it might be obvious, but then these all kind of beg questions, right? What is a good output? If you can't measure a good output, it can be very difficult to train. This is maybe why we've seen ChatGPT hasn't gotten better at like writing over the last couple of years when it's gotten a lot better at math. Because math is something that there is a good, correct answer, and writing is a little bit more ambiguous whether there's a good or correct answer. They all use vectors to calculate high dimensional math and map patterns in the data. So this has to do with the underlying architecture that they pretty much all run on, which is neural networks. And the way that neural networks represent information for the most part is through vectors. And a lot of things happen to like normalize and standardize those vectors and such. but that's something that can be important to understand. And later, I'm just kind of saying this so it's not like scary when you hear like, oh, it's vectors being passed around. They're just like sets of numbers. And a lot of the times you're not like going in and calculating those things. You're kind of handing that off to other algorithms to train it. And they rely on structures that mirror the brain. I mean, that's always super fascinating for me personally, but I think it's important to understand that like modern AI that is adaptable is because it is kind of mirroring things in the brain that we learned are adaptable as well. And something that I think is important to understand is that modern AI kind of is machine learning. So like there's sometimes these like charts that are like, here's all of AI, and machine learning is a part of it, and deep learning is a part of machine learning. If you were interested in taking a class at Cal Poly, taking Intro to AI would be more like this presentation, where you just at a high level explore the different kinds of AI, the history of it, the applications, those sorts of things. Where an intro to machine learning would be more of like the fundamentals and what is powering like modern day algorithms at the lower levels. And so I think that's something to understand is like you can also think of these modern systems as machine learning. And I know it's a lot of phrases today. The idea is not that if you're new to this, you're going to understand everything, but more that just like later if we talk about machine learning, you can remember like, oh yeah, that's the thing that powers modern AI today. Let's give some examples of machine learning, again, just to get a taste of them. So we have supervised learning. This is, I think, again, just an example on the right, but you could do a lot of things with it. I think sorting data into distinct categories is a good one. So you have a training process in which you're going to have a labeled data set. You're going to train on that. And then in the end, because, all of these are in the training set, you wouldn't put the apple back in because it might recognize like, oh, I was trained on that. That's an apple. You have test data as well. So ideally, you get like a new apple and a new orange, and you can sort that into a category. A way to think about supervised learning is learning from examples with clear answers. And that's when I said it's important like to have good good outputs, like to know what a good output is. That's really important here. Some examples quickly, just labeling them as cat versus dog. Is an email spam or not? And Face ID verification, is this the person I think it is? Self-supervised learning, this one's a little bit more complicated, but learning to predict the rest of an output. The reason I wanted to put it in here is because some people think that the previous example is how LLMs learn, but it's more self-supervised learning, which is where you have raw data, you have some sample data, and then some of it is lost. This could be like diffusion if it's like broken up where it's lost, or if it's like the end of a sentence, maybe you give it the first 80% of a sentence and ask it to predict the 20%. Based on its prediction, how right or wrong it is, you go back and update the model. When you do this thousands, millions of times, then you get a model that's very good at predicting the end of sentences, which fundamentally it does that token by token. We'll call them words. You get a model that's predicting the next word. That's why people say ChatGPT is just predicting the next word, because at a fundamental level, that's what it is trained to do. It is at every point of calculation is taking input and getting the most statistically likely next word. I think that's important to understand, but I don't think that's something that like defines an LLM. I think if you only think of it as like predicting the next word, you're going to miss out on a lot of the nuances that kind of scale up when it does it at a large scale. Predicting the next words, LLMs denoise images. Diffusion models actually work by taking a noisy image and denoising it step by step. And they can do that through self-supervised learning. And it's most of generative AI's foundation. And something to understand here is that that's really, really valuable, because you don't have to exactly have like a labeled data set of like, this is a good essay, this is a bad essay. It's kind of a workaround. If you can just have an essay, it can be good, it can be bad, but you learn to predict the next word, then you can learn the entire English language and every other language and like human speech, even though you didn't have to like sit down and like pay someone to label it. Of course, there is labeling and that sort of thing that goes on later in the process. LLMs are not just this. This is like one piece of like 10, but it is the most intensive and biggest piece. And then reinforcement learning. So when I was talking about the alpha models earlier, a lot of the kind of gains that happened in the past was because of reinforcement learning from trial and error, reward good outcomes to learn good behavior. So I think the most like easy way to understand this is going to be like if you imagine you had like an agent that was like playing Minecraft and it wanted to learn to cut down a tree. What you would basically do is simulate like 10,000 instances of Minecraft and have like someone controlling an agent controlling it, and you would reward the ones that 5 minutes later they have like wood in their inventory because that means they cut down a tree in some way, shape, or form. And then if you reward those, then the next time you run it, you update your algorithm and you're more likely to get those. And so that's like what's going on there is you kind of run a lot of simulations. And then if you have an output that you can test, you can then reward the instances that did the thing to get to the output. The only dangerous part there is you may not know what got to the output. So the reason that's dangerous is because like one, there's AI alignment and ethics, and the other reason is it might have like there might be reward hacking. It's possible that your Minecraft agent was like learning to go to a chest and like get wood out of it, and you didn't know that because you were just making sure they had wood at the end, and so you didn't know if they chopped down a tree or not. Playing advanced games like chess, protein folding prediction, and self-driving car decision making. Again, a lot of algorithms and things I'm mentioning use tons of different kind of systems combined, but they at least, fundamentally use this. Okay, so what is AI doing today? I'll just go over this quickly. But generative AI sounds like for us that AI kind of encompassed a lot of that, creating new content that didn't previously exist in some form, or maybe it did, but text, images, code. This is tools like ChatGPT, Midjourney, Copilot. Recommendation systems, they predict what you like or what you're likely to click next, or like how to get you engaged and stay on the platform. TikTok uses this for videos, Netflix for movies, Spotify for songs. Perceptions, which is understand visual, audio, and input, usually to do with categorization, but doesn't have to be. So Face ID, self-driving cars, is that a person walking? Is that a bike? Whatever. And speech to text models as well, but that could also be considered generation. It just depends the way that they're doing it. And language and interactions engages in dialogue or translation. So the way Siri and Google Translate works is not going to be the same way that that ChatGPT works. And that's why maybe we saw a lot of progress in like Siri or Alexa understanding queries, but then the responses to them were sort of canned and not that intelligent. Versus ChatGPT, it's generating something. It can come up with anything on the spot, right? It doesn't mean it's going to be right, but it can come up with something. Okay, so now I want to talk about the future of AI development, right? And I'm not going to make claims that like you should believe it's going to be this one thing or you should believe something else. I kind of just want to look at some maybe grounded statistics, look at what people are saying in this industry. I think it's always good to use your critical thinking and take these things with a grain of salt. If someone is like hating on it all the time, probably not the best person to listen to. If someone's like saying it's the best thing ever and it's going to solve all of our problems, probably not the best person to listen to. But why is it here to stay, right? Because I kind of used that example of crypto earlier because like crypto didn't really stay. It got a lot of hype and then it like went away. People will compare AI to the dot-com bubble, but like the internet stayed. And so I think I am going to make the claim that AI is definitely here to stay. If you want to make financial claims elsewhere, that's okay. It's the fastest growing consumer technology of all time. I think someone used the example that like Coca-Cola and OpenAI still have the same market cap, and they actually distribute products to about the same number of people. But the way they did it is completely different. Coca-Cola had to do this over like 50, 60 years and expanded in international markets because the world is sort of set up. So we all have software, phones, hardware. OpenAI could push a product that people liked. It could spread organically and get to the same number of people in about 2 years. That can be an interesting perspective to think about. Like I said earlier, it's considered a matter of national security. And if you know anything about US politics, as soon as something's considered a matter of national security, any other concern kind of gets thrown out of the window, unfortunately, because we should probably be a little more nuanced, but that's just the reality of it. And that's something we kind of have to accept and maybe push back on a little bit. But I think that's important for you to understand as well. Private investment in 2025 alone in AI is estimated to be $600 billion. I saw a stat this week that, for reference, the Interstate Highway Program, which built most of the highways around the country, when adjusted for inflation, spent $300 billion over 30 years. So that means we're going to spend twice that amount of money this year alone in just AI, infrastructure, investment in talent, and R&D. So like Economics usually puts money in places that are good. Maybe they put too much, they get too excited, but it's usually an indication of something that is real and a possible value. So I think it's something to take serious. And improvement has been accelerating and promising. I think there's been a lot of people pushing back and saying, like this is the end, it's not going to get better or whatever, right? I like to just think about the fact that like when you have a lot of money, and you have a problem, and then you have the smartest people in the world working on that problem, they usually find out a pretty good way of solving the problem. It may take them longer than they expected. It may take them less long than they expected, but people tend to solve problems over time incrementally. And I don't think AI is going to be any different. I think there are use cases we can think of where it would be really useful. And I think over time, the smartest people in the world, down to like everyone in this room, if we go on to work on AI, we're going to keep working in these areas and we're going to find ways to make it useful. If we just look at pure statistics, hopefully you guys know that the CSU and OpenAI have a partnership. They brought ChatGPT EDU, which is basically just a premium account, for free to 500,000 students, right? The CSU is probably a body that we all trust to make reasonable decisions because we all are under the guise of them. And they decided that, AI was relevant enough and being used enough to make a substantial investment to provide equal opportunity to every student to access it. I'll get into it some other time, but I think you should use EDU accounts. They're more private than regular accounts and all these things, but sorry. And then also here's this chart on the right, which is ChatGPT's weekly active users. So this is not just like signups or something. This is like someone who's like using it actively every single week. And in April this year, they haven't released an updated statistic since then, but it was 800 million people. That's a lot of people. That's like, one in seven, one in eight, or maybe closer to like 1 in 10 people in the world are using it every single week, not just like tried it out or something. Like they go back to it. So like this is a real technology that people are using, and it has consequences on what people are doing already today. What do AI labs want? Of course, I'm most familiar with the work that OpenAI does. So their mission statement is just, our mission is to ensure that artificial general intelligence benefits all of humanity. That's maybe something that's coined and marketed. Maybe they have different incentives at different points, or they make decisions that don't fully align with it. That's just kind of how companies and organizations work. But at least stated, I think these labs are saying that they want AI to kind of advance technology, right? And I think whether they say this or not, every single lab is working towards generally intelligent agents capable of doing everything humans can. That's kind of a weird statement if you think about it. Like that's their goal, is to make an AI that can do everything humans can. Some of them say like anything a human can do. Some of them say like any economically viable task. So anything that like a human does that makes money, like they want their AI system to be able to do that. Whether you believe or not that they can do it, whether you think it's going to be in 5 years or 50 years, it is important to understand like that's what they want. That's the stated goal. That's not like the thing they're hiding. That's like the thing they're saying out loud. So they're really going for something big here. And I think that's just important no matter what you believe about whether they'll get there or anything. But then there's of course normal business goals. They still operate in the system we live in. They want market share. Some companies more than others want engagement. They want people to stay on their platform, to keep using their tools. And they probably all want you to rely on their product rather than like switch between. I tend to think relying on one product is actually okay, just because the gains you get from switching aren't that great. If you track like every single little gain, but it can be important to understand and be a little more nuanced when you understand the goals that they want for their users. And then of course, like I'm talking a lot about like generative AI and like general systems, intelligence, agentic systems, whatever, but there's also like applied AI use cases too. So this company on the left is Figure. They want to do humanoid robots, and their goal is to just like get a humanoid robot into people's houses that will do chores for them. That's like the only thing they really want to do. There's autonomous cars. I was actually riding in a Waymo yesterday, so that was pretty cool. But that's like a more like just because you train a car to drive itself doesn't mean that it's going to go do something else. It's kind of like an applied case. And then medical diagnosis. There's really interesting things in the field of radiology where AI beat all radiologists like 5 or 10 years ago. And there was this prediction that they would lose their jobs, that like the amount of jobs radiologists would have would go down. And it's actually gone up, and they've actually started to make more money. and they've just started to use AI in their workflow. So I think that's again another positive case, so we can see something that maybe was counterintuitive but happened. Okay, and then just to end it off here, so look, after this, we'll just kind of talk about future meetings, some upcoming meetings, some opportunities, and I'll kind of be handing it off between Jason and some other people, but maybe just, kind of reflect on the meeting and discuss the following. What will the field of AI look like in 5 to 10 years? If I was giving this presentation in 5 or 10 years and I was talking about AI at that time, what would be the things I was saying? What would be some things that are like important now but aren't important then? And then what is the number one problem that we need to address in AI today? This could be super broad, like we need to figure out how to make it more optimized because the environmental issues are too great, or it could be like on the safety side or the ethics side or the application. It could be whatever. And there's no right answer to either of these. I just want you guys to talk to the people around you, discuss these, and then maybe Jason's gonna help facilitate that discussion, and he'll share some back with me. So we can all kind of be on the same page.
Yeah, I can just do the other notes and stuff like that, probably. Will make more sense to do it that way. Okay. Let's bring it on back. What are some in general, where we're going? What do you think the next 5, 10 years will look like? Any volunteers? None. Do you guys think we'll be a little bit lazier in 10 years?
Yes.
How do you think, do you think our jobs are gonna look the same as they are gonna be in 5, 10? Probably not. But, I think, oh, the echo's crazy. I don't know, Parker, what are your thoughts? What do you think is gonna look like next 5, 10 years?
Well, I don't think anyone knows. So I think if anyone tells you that they know, then you shouldn't exactly listen to them. But I think like things will change, and I think it's kind of like will be slowly and then all at once is maybe the term I've heard a lot, where like kind of I like to compare it to phones. Like, oh, like the iPhone came out and it was cool and you could have app stores, and then it was like 10 years later, like we're all addicted to like watching reels at 2 a.m. when we should be doing our homework. And that was probably something that you would have sounded crazy to predict when the iPhone came out. And then it just happened. And so the change will both be slow and fast. And I think it's important to just keep up with things, try things out, and being really adaptable nowadays is gonna set you up well in your career and life. So
Yeah, I think totally right. I think things will just kind of change in a few years, and you just gotta be open for adapting.
seeing where it goes, and then be ready for the change when it comes. What's our next slide?
Yeah, I can talk about future meetings and I'll hand it off to you. Or
Yeah.
can they hear me well? Okay. So yeah, our future meetings, they're gonna look a lot like this. So we'll have general meetings. These are the sort of mini lectures like you saw today. In the future, everyone will be in person. Sorry for that again, and for if the audio ruined it in any way, but hopefully it was still valuable for everyone. We'll have guest speakers sometimes on these Sunday meetings as well. It'll be Sunday at 1 p.m. We'll try to have something every single week. So you can always look at the Discord and check what it is, or you can just show up and figure it out either way. And if we're ever not here, we'll make sure to let you know. And the general meetings like these, like internal sort of lectures, we'll focus on high level AI lessons like this. Maybe we go over like just reinforcement learning or something instead. Usage and application, so how to get the best out of these models, and then ethics and societal concerns. And so we'll kind of be looking at the full spectrum of things that go into AI. And then we'll always try to be discussion based or interactive in some sense so that you can meet people, talk about it, try to articulate your thoughts and broaden your perspective as well. And then for our upcoming events and meetings, I'm going to hand it off to Jason. He's going to go over those. So Jason, you can just unmute so I can know when to change slides.
If I can get everyone's attention real quick, Parker just kind of overviewed what our upcoming meetings will look like and just, what we got in store for you. But as far as what next week entails, of course, right after this, we'll get started with our boot camp. But on Wednesday, we actually have Unwrapped AI. There's Santa Barbara-based startup coming. It's going to be the CTO and one of their senior engineers. They're going to be talking about the company. You're going to interact with them, learn a little bit more about what it's like to work at a startup. They'll also be inviting you to their hackathon. And the opportunity for internships, full-time roles. So it's definitely something definitely want to come. There should be food as well. So that's gonna be Baker 101. That's our Wednesday meeting, 6 o'clock. Yeah. Huh? It's gonna be application based. I'm pretty sure it's gonna be like at their company, so it might be kind of small, but it's definitely like they want people from CSAI. So definitely take a shot. Make sure you get your application. And then also next Sunday, we'll be doing our intro to AI APIs, just covering the basic AI APIs, getting your hands on, kind of get you started with those if you haven't used them before. And then of course, we're gonna have our boot camp after that as well. If we can just go to the next slides. Also, we're trying to get you guys an opportunity to sit down with a professor and maybe kind of just have lunch, talk to them, learn about the research they're doing. It's often hard to talk to professors outside of classes that you're taking. So if you can go ahead and scan this QR code, it's going to be a list of a couple other professors going to ask you some basic information about yourself or your interests or something like that. And then if, maybe you don't know any of them, then you probably want to check all the boxes, right? But maybe you do know some of them and you want to meet with some more than others. Their interest should be there as well. So if you can just kind of fill that out, that'd be great. And then we'll know who to kind of contact perhaps. And then all West, you want to speak?
Oh yeah, so hi everyone, I'm West. I'm the outreach officer, but I'm also the student director for the Cal Poly. I'll stand up. For the really?
Yes.
On the stage.
Stand on the spot.
Yeah, hi everyone, I'm Weston. I'm the outreach officer, but I'm also the student director for the AI ethics lab. So that's it's less of a club, more of a like research-based lab. So it's a kind of interdisciplinary partnership between the computer science department and the philosophy department. So really my vision for the program this year is that we want to really fully have that pipeline of looking at an ethical concern with AI and then talking with philosophy majors about that, talking with political science, policy-based people about that, and then turn that into a computer science project of how can we implement a guardrail that we come up with or a methodology adjustment. But really the main thing we're looking to do with it is promote those kind of important AI conversations. So if you like kind of the things we talked about a little bit in this meeting, we're going to be talking more about those in our first meeting, as well as it's going to be the opportunity to connect with research faculty. Really what we're looking to do is build up a group of students who knows about AI ethics, who knows about technical implementations of artificial intelligence, and then when philosophy professors, computer science professors are doing research, they can come to us and we have members who are trained and ready to go, because that's been a problem with some of these more interdisciplinary opportunities is there's not a central place to look for students. So yeah, we have 2 philosophy professors coming in. They're talking about AI alignment, which is kind of the practice of what is the foundation for like LLM responses? They talked about the kind of moral theories that should be used when crafting a ChatGPT response, basically about like what should be guiding that beyond just like a utilitarian economic model. But so super fun. If you want to scan this QR code, you can join the Discord. It'll be a lot of fun. And really, I mean, like, it's kind of too. It's like the official way. This it's gonna kind of be what we make it. So I'm looking forward to making a good partnership and connecting with staff members and making a good experience for everyone. So yeah, hope to see you guys there. Our first meeting's tomorrow. And Frankie Pilling at 6 p.m.
Take a photo of it in case you forget if you want, if you're interested. And yeah, I think we're going to take a little bit of a break just as we get prepared for the boot camp. Use it as an opportunity to go to the bathroom, grab some water, meet a new person. We're gonna get started with that in just a couple more minutes. I think, do we have a question slide after this, Parker? Is there one more slide? Any questions, any general questions, concerns? Yes, that's the end of it there. So we'll get started with the boot camp in like 5 minutes. Yeah. Cool. You just up here.
Good job.
Thanks.
You are good to go.
Okay. Good luck with the boot camp.
Awesome.
Let me know how it goes.
I need slides. I need stuff. Email to me.
Okay, bye, Jason.
Bye, Parker. Thanks for coming out.
Right now.
Have a good weekend.
Oh man.
Oh, no.
I don't like being on full face.
It's gonna go on here.
Not
exactly a flattering image. Huh?
Let's do one of those.
Yeah. I'll chime in.
Oh, yeah, you can
Yes,
chime in.
I'll chime in a little bit.
Here we go.
Okay. So like, I don't know. All right, everyone take a seat. We're gonna get started like as soon as everyone's done talking. Cool. All right, everyone. Okay. Hello again. I'm Jason. I'm your lovely president. But here we have Zach and Gus. They're two of our project leads, and they've done a really good job of trying to come up with an idea for bootcamp, and they're going to be the ones leading it. They're also going to be two of the people leading projects in winter quarter. So, good opportunity to meet them. It will be through this bootcamp. And of course, today is just going to be really an introduction to what we have in store, outlining the steps, outlining the milestones, deliverables, that kind of stuff, introducing you to the project, get you started right at the end. And yeah, why don't Zach, Gus, you can take it away.
All right, hi, I'm Zach.
And I'm Gus.
So there's our intro.
Cool.
So as Jason said, we're gonna be talking about the bootcamp project for this quarter. There we go. So Jason, do you want to explain what the
Yeah.
bootcamp is?
Yeah, of course. So it's gonna be basically the entire quarter, and it's really just a goal to kind of give you an idea of what project at CSAI are gonna look like. So just be a little bit of a hands-on experiment. We really try to break it down. AI is a really hard concept to kind of teach, and so we're trying to meet you in the middle somewhere. So hopefully, we can figure it out and get you through it. But basically, we're just gonna be doing it right after the workshops and lectures that Parker will be leading his meetings team. So just Sundays at 2 o'clock in this room. And basically it's just really trying to get you ready for the projects at the end. And if you finish it, you'll have a cool reinforcement learning snake project, and it will set you up for the projects as well. Yeah.
Yeah, just the goal is to get everyone kind of started, familiar with this kind of stuff and have some hands-on experience. Moving on. Cool. So this a little bit about the bootcamp. As Jason said, it's like an RL stake thing integrated with a website. So basically it's just reinforcement learning. So kind of like an approach to AI that is not necessarily just LLM everything. So basically it's just regular snake and then implementing some sort of model to learn how to play the game. Over time.
Making the right moves, trying to go the right places, and it literally will learn on the site as you are sitting there. So it will start off really bad, and over time, as people are sitting on the site, it will get better and better, and just gobble up all the apples.
Yes. Cool. So Muzart's not here, but otherwise this is me and Zach who are kind of leading. Muzart's the director of projects,
Yes.
if I'm correct.
Yeah.
Cool. So He's here in spirit. He'll be here next week, I think.
Yeah, and feel free to message us on Discord, ping us, whatever, if you run into issues with anything on the boot camp.
Yeah, and on that note, we actually just created a bootcamp channel on the Discord. And we put in some resources about the bootcamp if you want to kind of read ahead, as well as the repo that you guys will be forking later today. It's the baseline starting the project. So all the information, all your questions, you can either just DM us privately or just put them in the chat, and then that way everyone benefits from your questions. Because if you have a question, likely someone else will have run into the same issue, bug, or has a similar question. So don't hesitate to put your questions out there in the channel. I'm chronically online, we'll try to get you an answer ASAP.
Yeah. Cool. So the
Yeah.
demo link.
Start with a little bit of a demo.
I'm about to
Oh.
leave Canva.
That's totally fine.
There we go. So this is it. This is my personal website. And in the background, it's just a dot approaching the red dot, which it is learning how to do so. And over time, it will get better. Initially, it like doesn't really know what it's doing at all. It's completely random weights.
There we
But
go.
it will start to learn, and
Oh,
then
it's there.
it'll
we're
know
learning.
that.
Look, so it's like even in one take, it already learned, just a little bit.
Yeah.
And it's slowly making
It's way there. It knows it likes it. And then
Oh, it ran into itself there.
yeah, it got long enough to
So
run
that's
into
the first
itself.
time it got long enough to run into itself. And so now it's kind of learning, right?
Yeah.
And so really this was a project that Gus did last year. It's just a fun personal project. And when he told me about it, I was like, no way. And so we kind of were like, this would be a really great opportunity for you guys to kind of get a hands-on experiment. It's kind of a little bit software dev as well. So it's, it really covers like everything you might need to do a project later on. And it's hopefully, a pretty cool project as well.
Yeah, and so it's, as I said, I'll kind of speak longer so that you can see that this is actually working. So basically the fun part about this project is that it's not just like running locally. Like this is a website that has like other pages that I can click on. I'm not going to because it'll take me away from this, but it's just like a regular website. You can do some cool like Next.js integrations. I can't see where I'm clicking, but you can do like light mode and dark mode, which is so much fun. And stuff like that. And then on the back end, it's just like a WebSocket Python API that
They
does.
probably don't even know what that is. Or I mean, we'll
Yeah,
get
that's
there.
fair.
We'll break
We'll
it
get there.
down.
We'll break it down
you
for
know.
you. But the point is, we're going to expose you guys to some cool technologies. You don't have to know about any of this right now. And a bunch of that logic is already done for you, so you don't have to worry about that. And yeah, so now you can see it's kind of beelining it. Oh, right as I said that, it beelines it for the food more often than not because it knows that the food is it gets points when it goes to the food. Anyhow, I'll let this run in the background actually because it doesn't cost me anything. But cool.
Cool, yeah, I could talk about the timeline. So the bootcamp as a whole overview, kind of
Slide broken.
yeah, slide is broken.
Okay,
That's okay.
Well,
I think I can
okay,
go over.
okay.
So basically the bootcamp timeline, we're gonna first focus on front end first, right? Back end first,
Yeah.
my bad. Back end for the first 2 weeks,
Yeah, I will.
and then front end.
Oh, yeah, we
For the
we have this meeting. We have this meeting.
Yes,
And the next
yes.
meeting, we'll be talking more about
Yeah.
the parts of the project. We'll go over it into the repo and kind of tell you the file directory and what you're gonna be touching and what you might not be touching. And then really, we're gonna start with the back end, build out the back end, how you're gonna save the game state. And then we're gonna work on the front end. You're gonna actually make your own, custom colors, or like you can build variants to the project as well. And then really the last step is going to be doing the machine learning, the reinforcement learning part. And it's just gonna be like, we're gonna have 2 weeks for the back end, 2 weeks for the front end, 2 weeks for the AI. And I think that gives us like 1 extra week just for extra help. And by the end of the quarter, you'll have a fully working project.
Yeah, and
That's the goal.
one of the other goals that I kind of had for the reinforcement learning part was we're gonna go through walk through one model, and then kind of the rest of it is like you're kind of on your own. Like we're here to help, but
Yeah.
you're free to do some different testing
Right.
with different models.
Yeah,
and stuff.
and like Gus mentioned how the app is like the snake that's currently playing in the background in the other page. It learns over time because it gets points when it eats an apple, right? but then you can reward it differently, or you can try various things like, okay, more points if you stay on the left side or the right side. We can do all these different variants, and then we can see like who makes the best learning model, right? Who learns the fastest, who survives the longest. Can someone actually code it to do like the whole, map? How long will that take, right? So different tweaks will give you a completely different outcome as the person next to you. So really, in addition to being able to change the front end and what it looks like, you also can then tweak the brain. We're going to let you tweak the brain and try different algorithms, different weights, different learning methods, and then that will change the outcome there as well.
Yeah. Cool. So yeah, as we said, the starting point is just like kind of a structure and then game logic and then kind of scaffolding for the front end and back end so that you can follow along through the weeks and build it yourself. Cool. Okay. Well, we can jump into cloning. So the link here is also on Discord, so you don't have to type it in manually. It should be in the bootcamp. CSAI
we should just-
2025
We
bootcamp.
can go over tomorrow now.
Yeah.
Yeah, does everyone have access to the Discord? Is anyone not on the Discord? That was the wrong
Yeah,
question.
in the-
Raise your hand if you are in the Discord. That was the right question. I see so many more hands. Are you not in the Discord? Can someone next to them, or let's see, I have a QR code somewhere.
Can I make a QR code from here? Just
And then also, second question, who already has a GitHub account?
Oh, that is.
I think I asked the wrong question again. Everyone hands down. Who doesn't have a GitHub account? Okay, you
Okay.
can get one. You probably
Yes.
don't have to use it. Then let's go. Discord.
invite,
That saves us a lot of time, actually.
copy. Can I just go to like QR code?
Okay, right
QR code generate. Yeah.
And then does everyone see the bootcamp channel?
Set all cookies.
on
Look at
the
that.
Discord? Everyone have that?
Boom. This should work. Maybe.
No, I already got, we got, what is this?
This is
repo?
for this is a
For
Discord.
the Discord.
I got the Discord. Discord. You're good on the Discord.
Well,
Okay, can you pull up the repo?
yeah.
Look at it go.
No, it's going. Okay.
Okay, everyone should be able to pull up this repo. Does everyone have this? Does everyone have a laptop? Or everyone able to pull this up on their phone or laptop or something like that? Yeah. Okay. Does everyone who here knows how to do a git clone? Okay. Cool. So if you're familiar with that, you can already pull up VS Code or any IDEs,
Terminal.
or terminal or whatever, and then you can run your git clone. If you don't, just feel free to like raise your hand. And
I
we
can
might be able
walk
to send
through
some
it right
people
now.
walk you through it. Logan, can you help us out with that?
Here.
Um,
So if you have a Mac, you're in luck because you can just follow along with me. Basically you can just, if you're
Okay.
on the repo, to clone it, you just go up to this code thing here and then click it. And then you could just copy this URL to clipboard. And then you can open up terminal. I know it's scary, but it's super useful. And then you literally just type in git clone and then you paste that link. And then it'll just do it for you. Ta-da. If you run into like an error that Git is not installed, then we can help you with that. That's just probably a brew install. Oh, then we have to install brew, but it's okay. We'll get there if we cross that. We'll cross the bridge if we need to.
Is that last slide?
No.
No, there's much more.
Yeah.
There's a GitHub intro and stuff like
Yeah,
that.
But most people have GitHub, so.
It'd be great if we could come back to this. This should
Back
be
to
the
this.
last slide. Okay, this is the one activity for the day.
Well, technically,
What is the other activities for the day?
I'm just,
Why, this is, what, how is that? Why is it 25 seconds? There's 25.
Yeah, there's a lot of GitHub slides.
Anyhow.
Oh,
Okay, if
Okay.
you got there, great. If not, we'll cycle back to this at the end so that we can continue the presentation and then we can kind of help at the end
yeah.
with that kind of stuff. But for now, we are just going to do like a little bit of setup stuff as far as Git and IDEs and stuff like that. If you're already familiar with this, you can follow along or continue with the cloning stuff. And if you want to learn, we'll be explaining it here. Cool. So Git is basically just like a version control system. So instead of just having like a text file that you continually edit, and then if you make a mistake, you have to like do Control Z a bunch of times, you can basically kind of save state your work. And then if something happens, you can just revert back to a previous save state. So it's super helpful because you can track changes you're making. You can make sure like issues that arise, you can like find out where they came from and then fix them there and stuff like that. So GitHub is like a company. It's a website that hosts Git repos. Repos are just like the place, like the storage where all of those save states are stored. And yeah, it's like Google Drive for code. And it provides tools that we're going to show you guys in a moment that are all super helpful.
Yeah, so some reasons that people use Git and GitHub, it just makes working with other people a lot easier, especially using GitHub. You can pull different versions, make your own branches, and like merge together and everything. So it's definitely smoother collaboration, and we're definitely going to be using GitHub and Git repos throughout this club. Yeah, with all the projects.
So as we already went over, clone, this is useful, but like also, I don't know, it's so clone, you could take an existing repo and put it onto your local machine so you can work on it, edit it, and then make your own version of it. Essentially, branch is if you have like an existing code base and a bunch of code and you want to do something else, you can like branch off and do something else, and then someone else can work on a different branch, and you can kind of be parallelizing a lot of workflows so that you can all like have like a central starting point, and everyone can kind of like make their own changes or build their own features, and then eventually you can like merge all of that back in to like the main area, and then everything can be implemented that way and integrated. Commit is saving a version. Push is actually like pushing that commit to the save state. And then pull is to get all of the latest save state stuff from the central like area.
Yep. No, I think we're just gonna go over briefly, like
Yeah.
kind of what you just said.
Yeah,
For all of them. but
Yeah, it's just
yeah,
Git clone is a starting point here, and then branch is, yeah, you can just make your own changes. Keep your work separate from everyone else's so that no one like makes a change that you don't know about and then like bricks everything. So then just yeah, adding stages those changes, basically like just like kind of before you actually upload all of that stuff, it like stores it all. And we're here again. So this is actually git commit. So you can add like messages, and then you can save the snapshot, and then in git push, it actually uploads all of that stuff to the like storage space online and stuff like that. You can also simplify this a lot. Tools like VS Code have like extensions called source control, where it just does all of this for you. You just like make a bunch of changes, and then you type in a text box like, this is what I did, and then you click a button and it just does all of it for you. So it's nice to know,
Yeah.
but you don't have to work on the low level stuff like that as well. And then pulling is just like if you want to like see what someone else is doing, you can just like grab all of their save state stuff and put it on your computer so you can see it and stuff like that. And then you can, yeah. Let's see. Cool. Okay. Yeah, as I touched on earlier, VS Code's super easy to work with. There's also things like Cursor nowadays that have AI built in. It's really just a preference thing. JetBrains works, all of this stuff works. It's just whatever the best tool for this, for the best IDE for you is like probably just the one you're already familiar with, if you are. And if not, we recommend VS Code because that's what we all mostly use here. So yeah. Yeah, we can walk through downloading this if anyone would like some help. It's pretty easy. I think you can just download it as like an app from the internet. So that's pretty simple. And then I think this is a little bit too advanced.
Yeah,
If you
well,
want
that's
to
what,
touch
I
on.
mean, we have a Notion page. If you run into an SSH issue with like setting up your first Git like process, there's this Notion page. It should be part of the resources available that will kind of guide you through that. And if you're having that issue, let us know. We'll also kind of talk about that. But I did realize something. If you can go to the next slide, it says we're cloning the repo, right?
Okay.
This is the main step for today. But
Yes.
I'm realizing you guys are all going to be creating your own versions. And so if you already cloned it, that's great.
but you're gonna need, I think we want everyone to fork it first.
Yeah.
So that we're not all contributing
To the same code.
code.
Okay, yeah.
So, I'm unfortunately, everyone who's cloned it, you did a good job cloning it, but we're gonna need you to make a fork of it first, so that way, we aren't all overriding each other, so.
Yeah, that was a bit of an oversight on our part.
A little bit.
But yeah, so
At this point, I guess it's kind of, we're just go over questions, we'll be around, we wanna make sure that everyone, when they leave, they're like set up with their own fork and they could clone the fork and they're ready to code for next week. So I think a one way to just let us know that you're done, it would be to like maybe link your forked repo, like the URL for it, if you could put it into the bootcamp channel.
I'll make a thread for it.
Make
and
a
then
thread
just
for
put
it,
in
yeah,
there.
that'd be great.
Yeah, perfect.
Gus, can you also show how to fork? Does everyone?
Yes.
Yeah, let's start with that.
I think. Oh, it was. one
Yeah,
of those
It's
sides?
fine, it's fine.
Okay.
No,
It's just branching.
it's top right here. It's
Right
like
here.
fork. You just literally, you click that button. And then it will create the clone of the repo, or not, it will
Yeah.
fork it onto your
It'll
own.
fork it on, so as long as you're logged in, it logged in to GitHub, it'll just like do that. You can add a description if you want. And then you can just fork it. And then once it forks it, then you can clone that to your local computer.
Yeah,
And then the main difference between the fork and then cloning it versus just cloning it is everyone will have their own version they can work off of. So like their own project that are unrelated essentially. It's just the starting point is the same so that, as Jason mentioned, when you make changes to certain things, they don't break everything.
yeah, or like you don't
Overwrite other stuff.
write other people's.
Yeah.
Yeah.
Cool. So
But yeah, and then Gus, can you start the thread by just posting your own fork?
yes, I can.
Discord?
I'll
Let's
just
do
go
that.
ahead and grab
the
this link here,
URL.
and then I'll throw this in Discord,
Yeah,
which is here.
Do you think we need permissions?
I'm not sure if it does it need public or private. I have no idea. I'll try with Gus's.
Because you might need to add someone as a collaborator.
It wouldn't be collaborative as long as it's just public,
Oh,
only for private.
I guess.
That's the grid thread. Do like this, right?
I have no idea how Discord works.
Like,
Once. Let's create the thread.
okay,
Thread.
can you do it?
There's a thread, so the whoever just posted their own fork, can you post it in the thread that I just made? Post your threads.
Cool.
Perfect. Perfect.
Cool.
Um,
So yeah, we'll be around if anyone needs any help with anything, just like raise your hand, we'll come and help you.
Yeah.
Otherwise, yeah, this is kind of the main activity for today. If you finish this, you can chat with other people, help them out if you know what you're doing. And yeah, just kind of get to know everyone, because as far as I know, this is at least a good amount of the club.
Yeah,
so.
and like if you want to look a little bit ahead, there's the bootcamp resources in the channel that you can kind of look at on the Notion. But really we're just taking it kind of slow for day one, just making sure everyone's gonna be ready for when we get started with the actual coding. Some of it you might need to do like outside of the club as well. It won't all be coding during here, but you know, this time will also be like, after we're done with the presentation, it will just be like a work period for you guys to work alongside, help each other out. We'll be around to answer questions, this kind of stuff. But since it's the first day, we're not really trying to do too much. We just kind of want to give you a general overview of like, here's kind of the milestones, here's what's kind of expect, and hopefully that's going to be made clear, and you can check out the Notion for more information as well. But thank you all for coming out today. It's been a really long day. A lot of you started